Hello and welcome to our post-mortem presentation for Beehive, a member engagement application brought to you by Munir Abdullah, Zakaria Ahmed, Kevin Longworth, and Muaz Al-Haidar. Getting right into the introduction, so Beehive is an Android and web application that helps with member engagement and recruitment efforts within an organization. So for our goals and objectives, we want to be able to manage event information, simplify social media engagement, streamline group emailing efforts for organizations, and help with member engagement and recruitment efforts within an organization. Statement of scope, we want to create a piece of software that can create and manage events, allow members to sign up for events, and allow event managers to keep track of member attendance within those events. So for our major constraints, our major constraint in the development of Beehive is that the application is built by a nonprofit, so cost and resources must be set to a minimum, and the team learned much of the skills required as the project progressed. Software context, this application is developed by 4 developers. The software will be used for a company organization, and the software is supported on both web and Android interfaces. Moving on to requirements and analysis model. So for user profiles, an owner is a user with full administrative access to the program. A member is a user within the organization who can create events and give points. And a non-member is a person who is not in the organization. User stories. Event management members can create events, read events, update events, and delete events. They can also transfer events to different users, email those that are RSVP to an event, and change the attended list for each event. For group management, owners can create, delete, or update groups. They can also add or remove members within a group and email a group. For user authentication, members can log in, sign up, and reset their email or password.
So this is our data model. Starting off, you have a user, which has the attributes points, email, username, and user ID. It also has a role, which role ID, and a name, and it also is in a group, which groups have a group ID, name, and contact info. The leaderboard has the usernames, the user IDs, and the user points, and the users also manage the events with event ID, name, address, description, time, and date.
So for our functional model, we separated them between events and groups. For events, from the home page, you can go to manage events, which allows you to create an event, delete an event, or edit an event. An edit event, a owner is allowed to edit the date, location, time of event, event sign-ins, social media posting within the event, and the RSVP attendees. For groups, from the home screen, we navigate to the Manage Groups page, which allows you to, similarly to events, add groups, remove groups, and edit groups. Within edit groups, you can manage group members, remove group members, or add group members, add contact info for the group, and also send emails to group members. For our behavioral model, similar to our state transition diagram, we start at the user sign up. Once the user signed up, they can log in, and then when they log in as a member, they can view events. Also, they can reach the Contact Us menu, and also they can display leaderboard points. If the user is an owner, they can manage both groups and events. If the user is a guest, they can only view events.
So this is our data model. Starting off, you have a user, which has the attributes points, email, username, and user ID. It also has a role, which role ID, and a name, and it also is in a group, which groups have group ID, name, and contact info. The leaderboard has the usernames, the user IDs, and the user points, and the users also manage the events with event ID, name, address, description, time, and date. So this is the architecture design. We're using the MVC pattern. The controller interface is the model view. The model holds the data and is responsible for the modification of data. Since here the model is interacts with Sequelize, which interacts with the controller, and Express, which the user controls the controller, and then the view, and then the web interface uses React, and then the mobile interfaces uses React Native. This is the component design. Simply put, the server will run to an allocated URL, and then the URL will make HTTP requests to whatever the user does to get the new page and use the data. This is the software interface description. The only external system we're using is the Firebase servers, and then all of the software functions are being done using a human interface by interacting with the screen. Here's some examples of user interface. So these are the two login screens that we have for the web and mobile applications. As a general rule, we decided to keep orange as an outline for all lines and lettering. And then we also decided to keep all text outline except for buttons themselves. So moving on to our implementation details. So for our database, we use Firestore, which is a NoSQL document-based database, which allows for rapid prototyping geolocations as data pipes, including timestamps. But because of NoSQL, there's no schema and no relational queries, which can be a downfall, but also allows for lots of flexibility. So this is our web interface. So we use React for it because it allowed us to reuse data interface between web and Android, and it provides a basis for functional programming. One issue with state management because of React, it would have been limited if you use Vue or jQuery. This is for the Android interface. We use React Native because we could synchronize our data model with the programming language and allows for functional programming. It also had the same problem of state management, however, as React in the web interface. So here's what went right with the program. So overall, it's a general consensus that the team was able to deliver the program as the client asked. There's good communication, as well as pulling it together and planning stuff out and getting down into crunch time, and pushing through the end of the semester to deliver what our client wanted and make the best product that we possibly could.
For what went wrong? There are several things that the team agreed upon. Firstly, the decisions were not consistent. For example, originally we chose to go with an SQL database, but later converted the application to work with a NoSQL database, which is a pretty large change in direction. Secondly, we focused on things that did not matter as much, instead of looking at the bigger picture. And finally, the fact that we had to learn everything from scratch slowed our development significantly. Now, there are three main lessons that we learned from this experience. Number one, that we need to research our tools and technologies a lot more than we think we do. Number two, that we should make educated choices as to what tools we want to use and the direction we want to take the project from the very beginning, and to stay consistent with those choices. And number three, to do a better job of distinguishing each team member's strengths and weaknesses to ensure that the tasks assigned are appropriate and will be well taken care of. Our plans for the future boil down to broadening and deepening our understanding of computer science, from doing new and interesting projects to getting a more advanced understanding of theory to completing our degrees and finding a dream job. The team seems to have quite a few things on their mind, and that they want to explore and add to their portfolios. The skills we got the most help from actually came from our early courses like CIS 375 and 350. We also got a good amount of help from programming techniques from all the years that we have spent coding and learning new programming languages. The classes mentioned have provided us with decent general programming knowledge and insight into software development cycles that help better guide us throughout the trek that is senior design. Thanks for listening, and I hope you have a smooth next semester, Dr. Maxim.